Yeah, hi, this is Alex Glasgow. Today I'm going to be talking about some aspects of soil test results reports and what they mean. So I've got a soil test result sheet here. This is from Hill Laboratories, which is a large lab, very widely used in New Zealand, including in the turf industry. They do a lot of different tests, and like I say, they do a lot in the turf industry. So what I'll just do is go through some of the aspects of this test just to explain what they mean. But first off, when you fill in the form to do a soil test result, one of the things it asks you obviously is what test do you want to have done, and the first choice on their form is what's known as a basic test, and that test covers these things here basically down to volume weight. So that's what you get if you ask for the basic test. This result sheet also has this stuff here, which is, you can see there's some nitrogen and organic matter and other stuff in there. That's what's known as the organic soil profile. It's an extra test that you have to ask for, and it costs additional money. I'm not going to be talking about that today, but I will at some other point. But just today, we're talking about the basic test, which is these things here. Now, something to be aware of is this up here, where it asks you what the sample type is, and it's important to fill this in. And so just put what the crop is it ryegrass or kikuyu or parenua or whatever, and put that in there. And the reason you do that is because this medium range here is based on that plant's requirements. So if you want these interpretation graphs to be meaningful, it's important to put that in there, the ryegrass or whatever it is that you're growing. It doesn't change the actual results. The way they extract and determine is exactly the same no matter what, but it's all about these interpretation, this interpretation graph here. Okay, so that's important, that sample type. Then I'll just talk about these different variables that's tested. I mean, really, you don't get an awful lot in a soil test, a basic soil test. You get pH, you get phosphorus, potassium, calcium, magnesium, and sodium, which are known as cations, and you also get the cation exchange capacity. So just on these pH, I'll talk a little bit further about that on the next slide. Phosphorus, you can see this is called Olsen phosphorus. What that refers to is the type of extraction that they do. There are different types of phosphorus analyses that you can do, but the most common one in New Zealand is Olsen phosphorus. And the main reason for that is that this test has been very widely used and found to be very well suited to our soils. So my advice would be to stick to the Olsen phosphorus test because it's the most appropriate for the soils in this country. Down here, then we have potassium, calcium, magnesium, and sodium. These are cations. I'm not going to talk much about these today, but the main point here is that you can see here the units. This is milliequivalents per 100 grams. But also down here, you can see some more results for these same cations. You've got base saturation and MAF units. Now, these are not different extractions or different tests. They are just results that are calculated from the extraction they do. So it's just a different way of expressing the results. And we will talk more about how you can use these different soil test result forms and how you can interpret them subsequently. But that's the key point there, is that they do one extraction, but then they can calculate the results in different forms. Okay, now I'll just talk a bit about pH. Now, no doubt people have seen this graph before, but I always think it's a very useful graph to look at and understand because it tells you a lot about why pH is important. And you can see here that around neutral, so it's neither acidic or alkali, most nutrients are at their most available. And as you move away, the availability of that nutrient changes. So you can see with a lot of these major nutrients, they will become less available as the acidity increases, as the pH falls. Now, that explains to you why some plants don't grow well at low pHs, because they are adapted to growing in these conditions here with high nutrient availability. If they're in an acidic situation, they just can't obtain enough nutrient from the soil, and so they struggle and they lack vigor. But there are other plants, or some plants that are, because there's plenty of acidic soils around the world, highly acidic soils, and plants have grown in them and adapted to them to be able to prosper there. And brown top is an example of that. Brown top's a plant that's evolved under acidic conditions, and so it's able to cope well with these low levels, which probably mostly means that it doesn't need very much of a lot of these nutrients, because in the soils it's adapted to, there just isn't much of them there. Conversely, Poa annua is much more adapted to these kind of conditions around here. So this is a sort of a difference between these plants that can be taken advantage of to favour one above the other. So if you grow brown top under acidic conditions, Poa annua will struggle because it simply can't get enough nutrient. And another example that's not shown on here is aluminium. Aluminium is not an essential plant nutrient, but it's present in soils, and around neutral pHs, it's all locked up. But aluminium can be toxic to, well, is toxic to a lot of plants. So if the pH drops, aluminium becomes soluble and starts to enter the root zone. And plants that are not adapted to that, such as Poa annua, then are essentially poisoned by the aluminium. They can't cope with it. It's toxic to them, and they die out, or they lack vigor. Conversely, plants that are adapted to acidic conditions, one of the defining characteristics of them is that they can cope with the things that occur under those circumstances. So plants like brown top that are adapted to acidic conditions, if the aluminium level in the soil increases, brown top can cope with that. So it gives it a big advantage over Poa annua growing at lower pHs. So that's just some things to think about with pH and how it affects nutrient and other availabilities. So that's all I want to talk about today. So I'll just wrap it up there. Thanks for listening.